In the following video, we're going to talk about systems of linear equations. And we begin by introducing the general form of an equation. And so we're talking about the equation that has the form ax plus by plus c equals 0. And that is the equation of a straight line whenever we graph it. And so whenever we talk about two or more equations grouped together explaining a situation or in a problem, that is considered a system of equations. And if they're all of the same kind, then it is a system of linear equations, right? If they're all linear, then it's going to be a group or a system of linear equations because they all work together to explain a situation or a problem. A solution to a system of equations, in our case, in two variables, x and y, is going to be an order pair that satisfies both equations. Meaning, if you plug in a value x comma y into all of the equations and it gives you a true statement, then that order pair is going to be a solution. So, what do we mean by that? Here is on the bottom, scroll up, a system of equations in two variables, x and y. So we have the equations x plus y equals 5. That's equation number 1. And equation number 2 is going to be x minus y equals 1. So these two equations are describing for us some problem or some situation, right? They both are working towards explaining that situation to us. And so the system above has a solution 3, 2. Why is that? Because everywhere that you have an x variable, you're going to plug in a 3, and everywhere you have a y, you're going to plug in a 2, and it comes out to be a true statement, right? The question here is 3 plus 2 equals 5? And that is true. And is 3 minus 2 equals to 1? And the answer is yes. It's a true statement in both equations. Therefore, the point 3, 2 is the solution to this system of equations. Graphically, it would be the point where they intersect. So we'll talk about that later. Now, whenever you're given a problem and you're asked to determine if a solution satisfies a system of equations, what do you have to do? Well, what you have to do is plug in the order pair into each equation, simplify, and then verify that it gives you a true statement or not. So let's consider the following system of equations. X plus 2y is equals to 2. That's the first equation. The second equation is x minus 2y equals to 6. So these two equations somehow mathematically represent a situation, and we're trying to figure out if these given solutions here, A and B, satisfy the system of equations. I don't know, but let's figure it out. So for problem A, what we're going to do is plug in the points. So x is equals to 4, so 4 plus 2 times negative 1, does that equal 2 for the first equation? And for the second equation, that's 4 minus 2 times negative 1 equal to 6, right? I'm just plugging in the x values where they correspond. And let's simplify, right? So 4 minus 2, is that equal to 2? And is 4 plus 2 equals to 6? And if we simplify further, we see that yes, that is true. It has to be true for both equations. It cannot be true for one but false for the other. Therefore, it has to be true for both in order for that point to classify as a solution. So we can say that the point 4, -1 is a solution to the system. Perfect. Now, let's try that with the second point that we were given, -4, 3, and we'll do the same thing, right? We'll have -4 plus 2 times 3, and we're wondering, is that equals to 2? And -4 minus 2 times -3, and we were wondering, does that equal to 6? Now, we're going to simplify again in some fashion, and we'll have -4 plus 6, and you're wondering, is that equals to 2? And I'll leave it there. We can say yes or no in 1 second. And then the next one we'll have -4 plus 6, and you're wondering, does that equal 6, right? And so -4 plus 6, that is true. That is equals to 2. Perfect. Now, is -4 plus 6 equals to 6? And that is not a true statement, right? Therefore, the point -4, 3 only satisfies one equation, not both, and so it won't be considered a solution, right? It has to satisfy all of the equations that are in the system. If one of them is left out, then the whole system is going to be left out. What else do we have? Now, there are different methods for solving a system of linear equations. The first one that we're going to talk about is called the substitution method. Here are a couple of steps on how to do it, or a plan on how to approach almost every problem, I guess. And so this method involves converting the system of equations to one equation in one variable. And we do this by substitution, right? We manipulate, move things around, and so on. So here are the steps. Step number 1 will be to solve either of the equations for one variable in terms of the other. Move things around, isolate one variable, whichever one you like. Step 2 would be to substitute the expression found in the previous step into the other equation. The result will be an equation in one variable. So plug in what you found in step 1 into the other equation, right? Step 3, solve the equation containing the one variable. So you would now have an equation that only has one variable and a bunch of other things. So you want to combine like terms and move things around so that you have variable equals a number. I'm right here in step number 4, and back substitute the value that you just found into one of the original equations. That's going to leave you then with an equation in one variable, this time the other variable that you just, not the one that you just found, but the other variable, and simplify and find the remaining variable. The last step will be to check the proposed solution, kind of like what we just did in the previous example. Now let's try it. Solve the following system of equations by the substitution method. These type of problems are very free in the way that you approach them. You can do it any way you like. there's not a one way to do it, but you'll realize that there is a pattern that most problems are going to take. So you want to figure out which of those two equations require less work to solve for one variable. So I'm looking at equation 1 and 2, but I am kind of drawn to equation number 2, and looking at the x by itself, I want to solve for x. Okay, so that's what I'm going to do. I'm going to write the second equation by itself, but I'm going to solve for x. So I'm going to move the 2y to the other side, and I'm going to be left with x is equals to 2y minus 3. So now I have an expression for x, right? I know x is equals to this right here, 2y minus 3. What I'm going to do now is plug it into the other equation, plug it into number 1. So I have to plug it into the opposite equation, or the one that I didn't touch, the one I didn't manipulate. So that's going to look like this. 5. I'll write the original equation just so that you know what I'm doing. And this is what I'm going to replace, this x right here. Well, x is equals to 2y minus 3, so you're going to be left with this right here, 2y minus 3, and then I bring down the rest. So 5 times 2y minus 3, and then outside of the parentheses I have a minus 4y equals 9. So from this point on, we're just going to carry on our order of operations and simplification strategy that we should know. So distribute the 5. So I have 10y minus 15 minus 4y equals 9. Right, so notice that only what's inside of the parentheses gets the distribution property applied to. This minus 4 just comes down. It's not part of the parentheses. Then we combine like terms. That 10y is going to be combined with the negative 4y to make a 6y. And I'm going to move that 15 to the other side. So we'll have 15 plus 9, right? So we have 6y is equals to 24, I believe, right? 15 plus 9 is 24. And then divide both sides by whatever is being multiplied to the variable. And we'll have y is equals to 4. So we have one solution so far. Now we get to the point where we have to go back and back substitute, meaning this value that we just found, go back to the original ones, the original equations, plug it in, and then solve for the other equation. So I'm going to use equation number 2 again, which is x minus 2y equals to negative 3, because it's easier, it's got less things going on with it. And I'm going to substitute y. So x minus 2 times positive 4 is equals to negative 3. That means x minus 8 equals to negative 3. If I move the 8 to the other side, I have x equals 8 minus 3. And then we'll have x is equals to 5. Okay? So my solution, I'm going to assume that's the solution, is going to be the order pair 5, 4. Could I have made a mistake? Yes, always. How do I check to make sure? Let's use that equation number 1. We didn't really use it for much, but I'm going to use it. I want to check my solution. So I'm going to do this in blue, and we'll say 5, and what is x? It's going to be 5 minus 4 times 4, and is that equal to 9? Right, so is 25 minus 16 equals to 9. 25 minus 16, yes, that is 9. And now the question is 9 equals to 9? And the answer is yes. So I would also need to plug it in into the second equation, but I think it's going to work out. If you plug it in here, it's going to be 5 minus 8 is 5. Minus 8 equals to negative 3, and the answer is yes. So therefore, this is the solution to that system of equations. The next method that we want to talk about is addition method. So how does this work? In this method, we're going to eliminate a variable in the system of equations by adding the two equations together. So how does that look like? Consider the following system of equations. We have equation number 1 up here on the top, and equation number 2. And equation number 1 is 3x minus 4y equals 11. Equation number 2 is going to be negative 3x plus 2y equals to negative 7. So what happens when some things align and or are special? So let's go ahead and add them together. Equation 1 plus 2. We add straight down, right? So what's 3x plus negative 3x? And in this case, we have 0x. And what is negative 4y plus 2y? That becomes negative 2y equals to what's 11 plus negative 7, and that comes out to be a 4. And so notice how we have 0x. In other words, it went away. So we're left with negative 2y equals to 4. And if I divide both sides by negative 2 so that I can have the y by itself, I'm going to end up with y is equals to negative 2. And I have one of the solutions. Now I have to go back and plug it in, right? Because I need to know x as well. So we kind of have half of the work there. So that's the idea for it. Now, here's a rundown on the steps that we have to do. So addition method takes a little bit of preparation. Step number 1, rewrite both equations in the form ax plus by equals c. We want them to be in that form so that things line up. If necessary, this is step number 2, multiply either equation or both so that the sum of the x coefficient or y coefficient equal to 0. You're going to pick which of the which coefficient, the x or the y, do you want to cancel. So whatever seems more convenient, that's what you should go for. Step number 3 is going to be add the equations from the previous step, and the sum is an equation in one variable. That's what we want. We want to end up with an equation in one variable. Step number 4, solve the equation in one variable. After that, step number 5, back substitute the value obtained in the previous step. And you're going to do that into either of the given equations. Pick whichever one is easier to work with, and then solve. At the end, we want to check the solution in both of the original equations. Okay, let's do this problem. We have a system of equations, two equations in x and y, and we'll name them so that we know which one we're messing with. because we're going to have to rewrite this in a way that it's convenient for us. So we'll move this aside because we're going to need the room. So I definitely don't want to touch the original ones. I want to leave them just in case I have to go back and kind of check whether I made a mistake or I changed something, you know. So what do we want? We want them both looking like this. AX plus BY equals C, meaning I want the X and the Y all on one side. Do I have that going on in here? Definitely not. There's a mixture, there's something that needs to happen. So the system of equations is going to look like this. I'm going to move this 7y to the left. So I'm going to have 2x minus 7y equals to negative 17. Then on the second equation, I'm going to move the 3x to the left side. So I'm going to add 3x to both sides. So 3x plus 5y equals to positive 17. Okay, perfect. So step number one kind of done. I have both equations in the same form. AX plus or minus BY equals C. AX plus BY equals C. Now what? Well, here is the difficult part. You can choose to try to cancel x's or y's. Either way, the process is going to lead you to the same answer. And so what I'm going to do is try to cancel the x's. So I am going to multiply equation 1 by negative 3. So I need to get the coefficients to match. That's a 2 and this is a 3. So I need to multiply them by something. I need to multiply the whole equation so that it has a 3. Or I can multiply both of them so that they reach a common number. So I'm going to multiply equation 1 by negative 3. And I'm going to multiply equation 2 by the number 2. I hope you see what I'm doing here. So negative 3 times 2 is going to be negative 6x, and negative 3 times negative 7y is going to be positive 21y, and then negative 17 times negative 3 is going to be positive 51. So that's my new equation number 1. Equation number 2 is going to be 3x times 2, which becomes 6x plus 10y equals 17 times 2, which is 34. Okay? So this is why addition method may be a little bit difficult, because you gotta prep it so that two numbers match. Okay, now we have our x coefficients matching. We're going to add our two equations. So what's 6x or negative 6x plus 6x? Well, 0x. And then what is 21y plus 10y? That becomes 31y equals to 51 plus 34 becomes 85. And so I'm left with 31y equals 85. So don't be afraid whenever you get a fraction that is not too pretty. It's okay. I need y by itself, so divide both sides by 31, and we'll have y is equals to 85 over 31. So we found the y value. That's perfect. Now we need to go back and plug it in. So pick whichever one of the equations that you want. Either the original ones or the ones where we move things to the other side. Those two are the same. So at this point it doesn't matter which one you pick. They all seem kind of difficult. So I'm going to choose the original first equation. So we'll have 2x equals 7y minus 17. And this is what I'm going to replace, that y value, right? And that y value is the 85 over 31 times 7 and then minus 17. So 2x is equals to, well, calculator, right? 7 times 85 divided by 31, and you can leave it as a whole fraction like this. It's going to be 595 divided by 31 minus 17. And then you can go ahead and put this in parentheses in your calculator and subtract 17 from it, or multiply 17 times 31 and make it a fraction over 31, up to you. And what I mean by that is rewrite it as a fraction so that it has common denominators. So it would be 527 over 31. If you look at it, 17 is a fraction, 17 over 1, so you multiply the numerator and the denominator, and we're left with this, right? And you can do then 595 minus 527, which is going to leave you with 2x is equals to 68 over 31. And then we want to divide everything by 2 or multiply it by 1/2 so that we have x by itself. And so x is equals to, I'm going to multiply both sides by 1/2. And so I have x equals 1/2 times 68 over 31. And x comes out to be 34 over 31. And my final solution will be the point 34 over 31, comma, 85 over 31. A little bit difficult, but I think it's a good exercise to push you through a tough problem like this one. The next thing that we want to talk about is linear systems that have no solution or infinitely many solutions, right? Is every problem that we do going to have somewhat of a nice solution like we found in the previous problems, or what else can we expect? So in this problem, we're asked to solve the system regardless of how we do it. So let's figure it out. What can we do? We know two methods. We know substitution and we know addition method. So let's do addition method. Why not? Again, one of them is my one equation, the other one is my 2. And I'm going to move this so we can have more room. As you can see, it takes up somewhat of a little bit of room to transform everything. It's already in the same format, but what do I want to do? Let's say 4 and 6 have a common factor, a lowest common factor to be 12. So let's make them both be coefficient 12. So that means I'm going to multiply equation 1 by -3. So equation 1, I'm going to multiply it all by -3. And equation 2, I'm going to multiply it all by 2. Okay, so that's the plan. Now what does that look like in the end? We're going to have -3 times 4, which is -12x. What's -3 times 6y? It's going to be -18y equals, well, what's -3 times 12? It's -36. Then, second equation, everything multiplied by 2. So we have 12x plus 18y equals to 24. I think that's correct. So at that point, we see that they're good. They're good to go. We can add now because we have these coefficients matching. They have the same number, just opposite signs, and it is what we're looking for when doing it using addition method. I'll write that up there so that we know what method we went with. So -12 plus 12, it's going to be a 0x. What's -18y plus positive 18y? That's going to be 0y, and this is equals to -36 plus 24. I think it comes out to be -12. And you know, what's 0x plus 0y? That's just a 0. So you tell me, is 0 equals to -12? And the answer is no. This is confusing. We did nothing wrong. We took the original, we manipulated it so that we can use addition method on it to solve it, and we get to 0 equals to -12. And so this is a false statement, and this is considered to be no solution, right? Because 0 does not equal -12. End of story, right? Therefore, this system of equations has no solution. Okay? The next is going to be another problem, of course. And we want to solve this system of equations, and since the previous one we did by addition, this one we'll do by substitution. And it's kind of hinting that you want to do substitution because one of the variables is already solved for. So y equals 3x minus 2 is equation number 1. Equation number 2 is 15x minus 5y equals 10. I mean, you can go either direction. You know, you can do addition method as well. You can move this 3x to the other side. Whatever you want to do, you could. But just to keep it balanced and show a different method, we'll do substitution. So I'm going to plug in y into the second equation, and so I'll show you what I am plugging in, which is I'm replacing that y with the value of the first equation, which is y represents 3x minus 2 equals 10. So I'm going to distribute that -5, and I get -15x plus 10 equals 10. and further simplify, we have 15x minus 15x, that's 0x, it goes away, and we have 10 equals 10. Is the number 10 equals to the number 10? And that is a true statement. And because the left is identical to the right side of the equal symbol, this is considered to have infinitely many solutions. Or you can say all real numbers is the solution to this, right? What it says is that whichever pair of numbers that you select is going to work. Okay, you plug in a number, it's going to work for both equation 1 and 2. You find another pair of numbers that works, you plug it in, and it's going to work. So infinitely many solutions. And that's how you can recognize the different types of solutions that you can expect. One solution, no solution, or many solutions. And I think that's everything for this video. Thank you for watching.